Alright, so let's take a trip down memory lane. So some of these reaction types are going to be very recent in your memory because they were introduced in this section. But let's make sure that you kind of remember everything we've seen. So what was the very first type of reaction we showed in this class? If I remember right, we had condensation. And so what did a condensation reaction look like? How would you know a condensation reaction if you saw one? Well, you're going to have two molecules, two organic molecules, right? Maybe two things with OH groups on them. And then what do we get? You know, one of these could be an NH, right? But what do we get? Well, we're going to get one large organic compound. I didn't do the bat this time. And what else? That's right, a water. So in the last video I reminded you that water doesn't just show up in acid-base chemistry, it shows up in other places. Well, guess what? Here's one right here. Okay. We learned something right alongside condensation reactions. We had hydrolysis, which was basically the opposite of a condensation reaction. So we had something like, oh geez, we have a organic compound with an oxygen in the chain, or maybe nitrogen. And let's see, you know what? Let's make it interesting. There we go. Do something interesting. And water. So water is a reactant here. So what do we get? Well, now we're going to get two organic compounds, and we cleave it right here. And so you get two. You use the water to cleave that bond. You get two organic compounds. Now they both have OHs where they used to go to the same O. Alright, so those were the very first two types of reactions we learned about. And then what did we have? We talked about balancing chemical reactions, and alongside that I introduced combustion reactions. So take a second, see if you remember what the key pieces were for a combustion reaction. Alright, so you definitely had to have O2 as a reactant. You had an organic compound O2, and then you made CO2 and H2O. This is the fingerprint for a combustion reaction. So then we have to have something else. So let's throw old friend glucose back in here and balance it out. And so remember, when you want to go through the long form of balancing, I just happen to have this one memorized because it's just all sixes. You want to do oxygens last. Remember, because it shows up everywhere. So when you balance chemical equations, you can start with carbon, you can start with the hydrogen, but you do not want to start with the oxygen. That's the last piece. And so when you're looking for combustion reactions, there's wild card here, definitely O2, definitely CO2, definitely H2O. So it's the reaction of lighting something on fire. So you react something flammable with oxygen, and that something flammable is going to be made out of carbon, and you get CO2 and water as products. And that's what happens in a fire. You get water vapor and CO2. Okay, so what else we have next? Isomerization. We talked about isomerization reactions. Ugh. I blame the spider. It's still around here somewhere, plotting. Alright, so isomerization reactions. Well, what do those look like? Well, we're only going to have one reactant, one product. So what's the reaction? Well, you just rearrange, and so it could be, you know, it's generally going to be a sugar. I'm going to keep the carbohydrate real simple here. And all you're doing is keeping it as a carbohydrate. At least this is what it would look like in a biological system. And flipping, moving something around. So it's almost exactly the same molecule, but that subtle difference makes it a different molecule. That changes the sugar. So remember that these are all, you know, very specific. There's like a left hand and a right hand version, and we switched this carbon from being the right hand version to the think of it like the left hand version. So it's a subtle change, but it gets you a new molecule. It gets you a different isomerization reaction. Okay, and then you have redox, and within redox you have oxidation, and you have reduction. So how do you know something's an oxidation reaction? Well, you're going to increase the number of carbon-oxygen bonds. That's an option. So maybe you see something like this happen. Maybe we work some NAD plus in there or whatever. Or, I didn't do that though for spatial reasons, because I got to write some more here. Or what else can we do? Well, we can do a dehydrogenation. And so it looks something like that. So what's a reduction going to look like? Well, we just do the opposite. I'm going to be really lazy here. We can reduce the number of carbon-oxygen bonds. Hey, that looks familiar. Or we can replace a double bond with a single bond. Just flip them around and reverse them. So that was redox. And then, what else did we have? Oh yeah, the newest one of all. Freshest in your mind. Acid-base. So how do you know acid-base? Well, we're going to ID it from the right-hand side. We get something like that. We get a water and a salt. And then what do we have on the left? Well, we have our acid and base. We haven't talked about how to ID those yet. So this is the fingerprint region. This is how you ID the reaction type for acid-base. You just look straight to the right-hand side. So don't confuse it with condensation reaction. You get water over here, or what's the other one that gets water over here? We had condensation, wasn't there another? Oh, combustion. Yeah, combustion had water on the right hand side too. So you gotta be careful when you see waters over there. Do you see water with the salt? Do you see water with CO2? Do you see water with a big organic compound? That's how you tell them apart. So you see it with a salt, acid base, and so this could be what do you got? HCl plus NaOH, acid base. We'll talk more about these in the next section. So don't feel like you have to ID an acid and a base right now. You don't have that toolkit, but you can ID an acid-base reaction. You do have that in the toolbox right now. And so those are all the types of reactions we talked about in the class. A little reminder on how you can tell them apart. And hopefully this kind of helps you out through this section, because we have kind of we've stacked up a pretty good number of reaction types now. And so we are coming down the home stretch. There's only 2 more sections left in the class. We're going to talk about acids, which means we're also going to talk, it's acids and bases, just so you know, because they're opposite each other. It's like you got to talk about addition, you're going to talk about subtraction, you're going to talk about acids, you're going to talk about bases. And then respiration. And so that's that last section. That's the tip of the mountain. That's what we've been building towards. We're like, what is matter? And then we're going to be like, boom, ATP synthase, electron transport chain, glycolysis, all that stuff. We're going to be talking about all that stuff. So we've come a long way. So you've really built a good, solid foundation of knowledge to get you to that last section, and that's going to be like, some very, very deep biochemistry stuff that we're just, again, at the level we go over it in this class, but there's some fundamental stuff there. And I'm not hesitant to say that it was the part of biochemistry I hated the most. Oh man, did I hate metabolism. But I'll make sure to let you know why. I'll show the full picture. I won't expect. We're just gonna make fun of it. I'm not gonna expect you to memorize it or anything. And then we'll go through the level of detail I expect you to know in this class. So it'll be less. So I want you to see everything you don't have to know to make you appreciate the pieces that I do expect you to know, and realize that I'm not being unreasonable. I'm throwing away a lot of stuff there. And the figure I show you in the next section, if you want to be like a world-class biochemist, all you gotta do is memorize one figure. That's it. Seriously, that's all there is. But you'll see the figure and you'll see why. But yeah, so next we got acids. So we're going to focus more on these guys, and like how the body manages. We're going to talk about what pH is and how the body manages it, all that stuff. So there's a lot more biological factors in with this. Like this is This is stomach acid right here. You know, so like our bodies produce this stuff and we use it. So this is actually kind of like this is a biological molecule. But yeah, we'll talk about that next.